Good afternoon to all students. So today in this lecture we are going to learn the introduction to PLC programming, okay, which is the most important one, that is ladder logic or ladder diagram. So this PLC ladder programming is one of the best and visual programming languages which are being used in PLC programming, okay. And the great thing about this ladder logic is that it is much more visual than most programming languages. So people often find it a lot easier to learn. Now, for example, in case of Python and Java and MATLAB scripting or Scilab scripting, the programming is written in the code. So it's quite unfeasible for most of the people to read it and to understand it very clear. But in case of PLC ladder logic programming, it is a visual language, okay, visual language which can be seen visually. So you can see the programs or the blocks or the functions in a visual context, so that you can easily identify whether the system is on operating or off condition, okay. That is quite easier. The smart thing about ladder logic is that it looks very similar to electrical relay circuits. Okay, if you have seen the relay circuits, normally open, normally close, etc., you are able to know the logic diagram very in a clear manner. So if you have already know a little bit about the relay contact and electrical circuits, you can easily learn the relay ladder logic more faster. For that purpose, you need to be more accurate or informative about the relay logic or control and electrical circuits, which have, I think, you have learned in your previous semesters. So what is the ladder logic? Basically, ladder logic or ladder diagram is a programming language used to program a PLC, okay, and it is a graphical programming language which expresses logic operations with symbolic notation. It has symbols as code. Ladder logic is made of rungs of logic forming what looks like a ladder. Hence the name ladder logic. Okay, for example, I'll show you an example. This you can see here. You can visualize this as a ladder. Okay, two parallel lines, and this is for off, this is for on and off kind of things. These are the various symbols. This is what ladder logic looks like, okay. So that is the reason why it is called as it looks like a ladder, it is called as ladder logic diagram. Ladder logic is mainly for bit logic operations, okay, means bit control 1 0 operations, although it is possible to scale a PLC analog input, and even simple bit logic operations can be advantageous in more advanced PLC programs and system programming, okay. So the people that sets the standards for logic ladder logic is PLC open, okay. You can find out through this PLC open the ladder logic. Ladder logic is not only a programming language for PLCs, one of the standardized program languages, okay, for PLCs. It simply means that ladder logic is described in a standard. What standard is called as IEC 61131-3. This is what standardized code for the PLC programming languages, that is ladder logic. But for now, the only thing you need to know is that there is a standard describing the programming language. This is what standard. It doesn't need to know a bit more about this, but it is your standard. If you search this in Google, you can see here. If you search this, it will show you programming language edition, okay. It is called a toolbox. So this
specifies syntax and semantics of programming languages for PLC control. Okay. This is what you need to know about. Just you need to know the basic things. Okay, IC standards. Then introduction to ladder logic. So
With the ladder logic, there are a few things you should know about the programming language. Okay, before going through ladder language or logic, you have to make sure about
and know about the programming language. You should know
is invented, because then it will be much more easier for you to understand the ladder logic, especially if you have prior experience with electrical circuits and relays or some boolean logic. I think you have learned electric circuits in your network theory, you have learned boolean algebra in your analog and digital control. Okay,
so I think you might have some uh, information.
relays in power system analysis. So if you know the basic things related to these three things, then it is very easy for you to learn the ladder logic. Okay, so ladder logic diagram or or programming is invented for technicians which are going to work on PLC. So as we know that it is a graphical programming language, which means that instead of text, the programming is done by combining different graphic elements. Okay, different visual symbols, as we have seen here. These are the symbols, these for open and this for close, I think. Okay, these elements are called as, I'll show you once again a better version of this. Hmm. These are the symbols. Okay, as if it is closed, okay, if it is open, you can see here these are the symbolic instructions. Okay, and these are called as symbols. One of the smart thing about the ladder logic symbol is that they are made to look like electrical symbols. Okay, these are quite electrical symbols. For example, this can be seen or visualized as a horizontal capacitor, etc. Ladder logic was originally created for technicians, electricians, and people with an electrical background. So, people who are used to look at electrical diagrams and schematics. Okay, so it is developed for the people who are aware of electrical symbols and electrical background. For that person's ladder logic has been created. Okay, and ladder logic instructions and symbols are similar to that of
Symbols. So
just as an electrical diagram, ladder logic have symbols for contacts and relays, which are called coils in ladder logic. Okay, for example, this diagram or this symbol is for output coil. Okay, the symbols may look a little different from the ones you have find in electrical, but they almost have same functions. Okay, so this is for a output coil, you can see here. Then different programs, different like latching. Okay, here examine if closed, then for coil. Okay, the connected in parallel, etc. After that, examine in open. This is for examine if open instruction or symbol. If you are a technician who works with PLCs, then there are some websites which is given in this hyperlink is given here. This if you want to learn more about the PLC ladder logic in a deep manner, you can go through this website and you can have some tutorial. Okay, so how to read ladder logic? So another difference between ladder logic diagrams and electrical symbols is that is it the way it is drawn. Okay, so in case of electrical schematics, they are drawn horizontal. Ladder logics are drawn vertical, okay, in a vertical manner. Now this is what a ladder logic instruction looks like. It is for examine if open instruction or symbol. It is drawn, you can see here, it's quite similar to that of a capacitor, okay, symbol of capacitor. So electrical uh, schematics are drawn horizontal, but ladder logic are drawn vertical. So the best explanation are, for example, it is easy to read, okay. First of all, ladder logic is easier to read because it is natural for the eye to go from left to right and then down to next line, okay. It is in a sequential manner, just like when you're reading, okay. Whenever it is like, if you're reading a book, of course this applies only to the people living in countries where the reading is done from left to right, okay. If in your country, in for example in India, we read from left to right, okay. So ladder logic diagram is also quite similar to that. I'll show you an example. It can be read from left to right, okay. It can be drawn on computer. So when you draw ladder logic on computer, you will make one line at a time. So as you draw more and more lines, they will stack on the top of each other, making up what looks like a ladder. So the best way to look at a larger ladder diagram with many lines is to scroll vertically along the screen. Okay. So then order of execution. So the drawing ladder logic vertically is set. It is to set the order of execution. So the order of execution is nothing but it shows how the PLC will run your ladder logic. To be more precise, in what order your ladder logic instruction will be executed by the PLC. So a PLC will always start at the top of your ladder logic and then execute its way down. For example, in this ladder logic diagram, your ladder logic will start from the top most, okay, then it will execute and it will end up to the downmost part. So then relay ladder logic we are going to see. So as I said before, ladder diagrams can look a lot like electrical schematics going vertical, okay, going vertical in downward direction. Most people learn to draw ladder logic diagrams this way by building them as electrical schematics, but there are some differences, okay. This is why I will advise you to learn in a different way. So the problem is here that electrical control system and the PLC work in different ways. So the differences are, the PLC takes one ladder logic line and execute that and then goes to next line. The PLC will take one ladder logic line, then execute, and then it will take a next line. But in electrical system, there are multiple lines which are current pathways can be executed at the same time. Okay. In case of ladder logic diagram, one line at a time. In case of electrical systems, multiple lines can be executed at the same time. Executed means activated or turned on. So by keeping this crucial difference in mind, it's time to learn some ladder logic. Okay. So ladder logic basics we are going to learn today. So the first thing you will see when you create a new piece of ladder logic is two vertical lines. You can see here. Two vertical lines, okay. It is in between these two lines your ladder logic goes, okay. The difference is just, okay, an adjunct line, okay. So when you draw ladder logic, you will draw vertical connections between these two lines. Each of those is called as a rung, just like a physical ladder, for example, like this, okay. So these are two vertical lines, okay, here for the two parts, and then the vertical lines is been crossed by a adjacent line. Okay, this is called as rung. So in these rungs you can put any ladder logic symbols to create the logic you want. Okay, these are the rungs, this vertical line and this vertical line. So in these you can create or put any of the ladder logic symbols to create the logic you want. So as you can see above, I have put numbers on each rung. Okay, first rung, second rung, third rung, fourth rung. This is to understand how the PLC hardware will execute the ladder logic. So, but how does the PLC execute our ladder logic? So one rung at a time. It is not like that of electrical systems, means multiple lines are activated at the same time. So PLC logic will start from rung 1. Okay, it will execute all the commands, okay, here. Then it will start the rung 2, then 3, then 4, then execute the particular command. So this might be the one of the most important rules of a ladder logic. The PLC only executes one rung at a time, then execute the next. In fact, the PLC only executes one symbol at a time. So there are no multiple symbols activated at time. So for example, the PLC is starting at rung 1, then it will go to this block. This is normally examine is if closed, okay, instruction. It will execute the examine if closed, and then it will execute again this, then it will execute examine if open, then it will go to the coil, then it will execute the function. Okay, so ladder logic programming with instructions. So each symbol in ladder logic is an instruction. Each symbol means these all the symbols are the instructions in ladder logic. This can in the beginning be rather confusing, but don't worry guys, I will explain this with very simple example. So let me start by giving you a simple example. So in this first example you will be introduced to the first ladder logic symbols. So what are these instructions or symbols? Are basically, so they are basically logic instructions that make you able to create a piece of logic. Okay, this whatever you are seeing is a piece of logic. That piece of logic is your ladder diagram or PLC program. If you take a closer look at the example below this example, you will see two instructions or two symbols. Okay, this is the first instruction, this is the second instruction or symbol. So this figure is for two instructions in one ladder logic rung. You can check. So first one is, you can check here, and then first one is examine if closed. The first symbol we are going to learn in our ladder logic is examine if closed. Okay, this looks like, examine if closed looks like this. Okay, it's quite capacitor in a vertical manner. This is a conditional instruction. It means that you can use it to check if something is true. For example, check if a bit is on. For example, I'll show you. So in this rung, first rung, this is your examine if closed. Okay, means these instructions will allow you to check if a particular bit is on or only on. Okay, for off this is different, it only checks if it is on. Okay, as you can see, there is a name above the instruction symbol. Okay, 10.0, they have given, they are having names, okay, for these symbols. This is the address of the specific bit. Okay, for example, I want to check a bit at the address 10.0 if it is on. So I can put my or I can draw my what you called as a simple examine if closed symbol, and then I can check whether the bit at address 10.0 is on or off. Okay, this is how it works. The address is specific. Okay, specific bit. This instruction will examine, in this case, a digital input. It could also just be an internal memory bit or even an output. Okay, examine if closed is also known as normally open. Okay, if you have gone through the relays, this symbol in that language is for normally open. It works basically on the same way as a normally open contact in an electrical circuit works. Of course, normally open contact has no memory, but as a condition. The condition is whether the contact is activated or not. So the condition could be a finger pressing a button. Okay, it just shows the condition if it is on. The main point here is that each instruction has to be assigned an address in the PLC. Each instruction here should be assigned an address. I'll show you an example like here. Each instruction have some address. Means for example here this you can see here. Okay, so inputs and outputs are also bits of memory in the PLC. So in the above example, the examine if closed instruction has been given memory address as 10.0 or IO.0 as a condition. This address belongs to the first input of the PLC. Here how it works, okay? So when the PLC scan cycle starts, the PLC will check the state of all its input. Then it will write in the memory the boolean value for these states 0 or 1. Okay, it will check by the normally examine if closed switch. Okay, then if an input is low, the bit will be set to 0. Okay, low means 0. And if the input is high, the memory bit will set to 1. Okay, high means on. Next one is output coil. This is the symbolic diagram of output coil. Okay, ladder logic output coil. So the instruction itself even has a place in the PLC memory. So the PLC will put there is the result of the instruction. Okay, this instruction has a memory in the PLC, and the result will put in the space of this instruction. To see what the PLC uses that result for, we have to look at the next instruction. So an output coil is used to turn a bit on and off. Okay, first one was to check a bit whether the bit is on. Next one is to check, next one is to command to close or open a bit, or to turn a bit on or off. As you can see, the symbol is placed on the right side of the lung. You can see here. Okay, here we are going to check if a bit is on. Here we are going to command to turn on or off a bit. Okay, this means that all the instructions that come before in the same rung act as a condition for that instruction. Okay, so in our example that we for in our example that will be result of the examination if close instruction. Okay, so let's check how the results of that instruction could be. Okay, we'll check here. I'll minimize this figure. Okay, you can see here. So PLC scan, okay, inputs are 10 byte, then program runs, that is the result. Okay, so PLC will scan. Okay, you can see here, this is a PLC, these are the input and these are the output. Okay, so here it is, there is a switch of 20 volt to 24 volt DC. First of all, we have to scan the inputs. Okay, so you can see here input byte and output byte. You can see an input byte IO, output byte QO. Then these are the different addresses for input and output. Okay, then it will check. For example, this figure will run again. Okay, this is a graphical image. Okay, if firstly it is off, then the values are 0. Okay, if it is off, all the inputs will be 0 according to the address. Then it will run the program. The value is given to the back of this. Okay, if it is off, it is given to this. Then the output will set. Okay, then it will, if you off, it will, after after closing the switch, we can see here there will be first input and all the outputs will be 0. Okay, then run the program again, address given to that, and return to big okay, return to back of this. Okay, this is a basic example. Okay, we are going to see in a deep manner. So in the animation above, we can see that the PLC first scan all the inputs. Okay, the state of these inputs are then saved in a memory byte. The PLC will scan the input. If it is 0, it will be saved in the address as a 0. Then repeat for all. Then it will. The state of these inputs are then saved in the memory byte. Okay, these are the memory. Oh, so the memory byte is of 8 bits next to the each other. For now, you don't have to think too much about it. So when the PLC has the state of all the inputs saved, the program will start to run. Okay, the PLC will scan the input, it will then see the states, and then the program will run. The first instruction to be executed is the examination if closed or normally open. Okay, the result of this instruction will be same as that of the state of memory bit. So it makes sense to call the instruction normally open. In a normal state, when the memory bit is 0, the contact will open. Okay, if it is 0, the contact will open and the result is 0. But if the memory bit is 1, the contact will close and the result is 1. Okay, you can see here. So we will stop here today, and I think today we have learned a lot of basic things regarding the PLC ladder logic, importance, the need, advantages, and then basic symbols. Okay, output coil and examine if closed. Okay, so next, in the next lecture we are going to learn the other symbols and simple 2 to 3 examples regarding the relay logic or ladder logic. Okay, so till then, watch the video. If you have any doubt, you can ask me, and till then, take care and have a nice day.